Let's talk about chapter 4.3, one of my favorite ones. Not to have favorites or anything. It's about optimization and real-world modeling. I'm a member of a professional organization called Informs, and their motto is save lives, save money, solve problems. It's the Institute for Operations Research and Management Science. I'd be happy to talk with you about career opportunities in operations research. You could also think of it as advanced analytics. So here in this chapter, we're going to take real-world problems and turn them into formulas. Maybe that's not a surprise. And the process of doing that, you could say, is making a math model. And then from the formulas, we'd like to optimize something, maximize the number of lives saved, maximize the amount of money saved, or minimize the amount of money lost or something. A lot of times these formulas will have more than one independent variable. So we'll say formulas with many independent variables. And it might just be more than one. And we could solve those with software. There's something called Solver in Excel. And we talk about that a lot in math120 and 560. So ask me more about that if you want to know how to solve 200 variable problems for free in Solver. Since we're in Calc 1 and we want to look at kind of the nuts and bolts of how these things work, we want simpler problems. So we're going to spend time turning these formulas with many independent variables into formulas with just one independent variable. And then we're going to apply the methods of chapter 3 to find mins or maxes. And how do we do that? Our catchphrase was take the derivative, set the derivative equal to 0, and solve. But there was more than that. What else was there? Take derivative, set derivative equals 0, solve for x. What else did we have to think about there? We had to also think about where f prime did not exist. We had to think about the endpoints. If we had a closed interval, we had to think about local mins and maxes versus global mins and maxes. And what's a good way to check all that? Maybe graphing it. Now, there's going to be some problems where there's a little bit of algebra, maybe not as bad as the quadratic formula or anything, but this section is all about doing the setup, taking a real-world problem or sort of real-world, and making a math problem out of it. And if there's algebra to be done, we want to just let software do that, Wolfram Alpha or something. So we'll say it's okay to use Wolfram Alpha to do algebra. Wolfram Alpha or similar. All right. And before we get started on the main stuff, there's an accounting thing I want to remind you of. Let's start with something simple like buying fruit from the supermarket. Let's say bananas are 20 cents a pound. And let's say apples are maybe $1.50 a pound. And you want to buy, let's say, 3 pounds of bananas and 2 pounds of apples. How much is it going to cost? So we're going to buy 3 pounds of bananas and 2 pounds of apples. How much is it going to cost? Can I just say, well, I'm going to add the 20 cents and the $1.50, get $1.75? $1.70? That would be the 20 plus the 150. Hopefully everyone has figured out it's not going to be that, right? Because that didn't even respond to how much we wanted to buy. I could buy, if that was how the logic worked, I could buy 3 million pounds of bananas and 2 million pounds of apples and still only pay $1.70. Would you say I pay $1.70 per pound no matter what? Well, if I buy 1 million pounds of bananas and 0 apples, I'm only going to pay 20 cents a pound. Or vice versa, I'm going to pay $1.50 a pound if I buy no bananas. So I can't just do that. What you have to do, and you're probably not surprised by this, is you'd have to say $20 per pound of bananas times how many bananas, banana pounds, plus $1.50, or you could say $150 per pound of apples times how many pounds of apples you're buying. So basic accounting, but it's something that's easy to forget in the rush of all the other math that's going on. So price per unit times number of units, let's keep that in mind.